And so welcome back, boys and girls. This is your hostess, Miss Tamal, and we're going to continue to build and grow our beautiful brains as we continue on another segment of the Partial Products Game Show. So you'll need 3 items today. Your first item, a sharpened pencil with an eraser. Your second item, your marble composition notebook for scrap paper. And your third item, your lesson packet. This is Math Lesson 18. So if you are ready to win big, go ahead and press play to continue. So of course, we're going to start with what we've already learned and all of those background knowledge of big ideas that we've sort of built together. So big idea number 1, I'll let you choose. Is it door 1, 2, 3, 4, or 5? Which one will you choose today? Let's go to door 5. So I'm not going to tell you, but I would love to see if you can remind me when we talk about multiplication equations, whether we are multiplying by 2-digit by 1-digit numbers, 2-digit by 2-digit numbers, or 3-digit by 1-digit numbers. Right now, the numbers that we multiply have a specific name. What is that name? Yes, 23 and 16 both represent our factors. Give yourselves 2 claps. Nice. Now talk to me about 268. What does that number represent within a multiplication equation? I know you know this one. Yes, honey. It is the product. Give yourself 2 claps. All right, let's go on to big idea number 1. I'm going to let you read this one on your own and then give me a thumbs up when you're ready to continue. Great, so we know that we can decompose factors into addends. Make sure to double check that when you decompose your addends here, they add back up to this factor. So 10 plus 22 equals 32. 30 plus 24 equals 54. But that's not the only way that we can decompose a factor. We can also decompose a factor into addends based on place value. Let's check this example out. So we've been using this way a lot because it makes multiplication very, very friendly for us. So we're going to get a chance to practice that example behind us today using decomposition into addends by place value so we can get really, really good at it. Big idea number 3, I'll let you take that one away. Perfect. Now go ahead and read that one out loud to me. Great work. Big idea number 4, all about the distributive property. We know that the distributive property of multiplication means that a product of 2 factors is equal to the partial products of the 2 decomposed addends and the other factors. We're going to keep using the distributive property as we continue to multiply today. And in our last big idea, when we are multiplying by multiples of 10, 100, or 1,000, we need to make sure we are multiplying the non-zero digits, or the digits with value, by the multiple of 10, 100, or 1,000 that the number represents. So let's actually practice that big idea today, because we've started now multiplying 2-digit numbers that were both multiples of 10. So we want to continue to sharpen our muscles. All right, which door will you choose? Yes, that's a great choice, door 3. What is 40 times 80? What is 40 times 80? Which ones are you eliminating right away based off of your process of elimination? I like that. B has to go. No way. This product cannot be less than a factor. 12,000, no way. Because if we even multiply our non-zero digits together, that's going to be 32. There's no way that the product can change. So you're down between A and D. Which one for 100? Ding, ding, ding. Good job. I agree with A. Let's go to the next one. What is 70 times 20? Ding, ding, ding. Good job. 1,400. So let's actually unpack that one just so that you can get a refresher before we go for the big money. So the way that I solved 70 times 20 is that, of course, I started with the non-zero digits, and those were 7 and 2. I know that 7 times 2 is equal to 14. So then, since 70, which was my first factor, was a multiple of 10, I multiplied 14 times 10 to get 140. But wait, but wait, but wait, wait. The second factor is also a multiple of 10. So look at what I had to do next. Then, since 20 was also a multiple of 10, I had to multiply 140 now times 10 to get 1,400. Let's see if you can rock this next example out. 30 times 50. What is the product of 30 times 50? Start with your eliminations. Now move on to multiplying your non-zero digits. Now multiply. And what did you get? I agree. Good job. All right, our next one. What is the product of 40 times 30? I love how you're just telling me the process that you're taking. Yes, confidence. I agree. Good job. What is the product of 80 times 30? Yes, excellent work. C, 2,400. That completes our do now. So now we're going to head over to the guided practice where we're going to solve this example. Let's head to door 6. You can follow along on page 1 of your packet, where our guided model example today is 73 times 19. Time for me to put it on the big screen. So let's look. 73 times 19, and we have our steps, of course, that are going to help us jog our memory. So first, we want to start by decomposing into add-ins. Today, as we decompose into add-ins, we're going to focus on how do we decompose by place value so that we can continue to multiply in friendly ways that help us. And then what's next? Yes, the area model. The area model is going to be a great organizational tool for us to keep our partial products together as we use the distributive property to multiply. And then once we have all of those partial products, we close it up and we add them because partial means part of. So we need to add all of our partial products together so that we can find the final product. So if you're ready, get ready, grab your pencil, and let's work along with this. Let's start with decomposing into place values. All right, 73. Let me start by drawing my branches. How many tens do I have in 73? Yes, 7 tens. Now, what is the value of 7 tens? Good job. 70. Talk to me about how many ones are in 73. Now, what is the value of that? Yes, 3 ones. All right, let's move over to 19. Talk to me. How many tens are in 19? Yes, just 1 10. And then how many ones? Absolutely, 9 ones. We just completed decomposing into add-ins by place value. So now let's head over to the next step, which is going to be our area model. So let's go ahead and draw. Wait. Big important question. How many parts will be in our area model? And then how did you figure it out? Yes, I'm hearing 4 parts. Now, how did you know it was 4 parts? Talk to me. Yes. Absolutely. Let's go ahead and count our add-ins, just to double check what our friend is telling us. Get ready, Kat, with me. 1, 2, 3, 4. So we're going to draw a 4-part area model because we have 4 addends. Let's go ahead and draw an area model that's going to have enough space for me to do so. Draw along with me. Now, before I draw my parts, I want to consider the relative size of each one of my addends. Just so that I don't get tricked, it helps me to start by labeling the overall factor, and then I could think about how did I decompose it. So here's an example. 73. I'm going to switch it up. I'm going to put that factor as the width. So I'm going to write 73 right here. And then 19, I'm going to make that my length. Let me put 19 right over here. These were my overall factors that I initially started with, but we know we decompose them into addends based on place value. So now let's actually split each width or length based on how we decompose that factor. So 73, we decomposed it into 70 and 3. Well, I know 70, way larger than 3. So when I draw my area model and I split this part, I'm going to actually put it over here because 70 is way larger than 3. Now let me write my dimensions. This side is 70, this part is 3. We know opposite sides of a rectangle are equal. So let's go ahead. If this is 70, then that means this piece needs to be 70. If this is 3, then that means this piece is 3. Perfect. Now we know this equals my original factor that's right there. Let's head over to 19. How can we split that? Yeah, well, relatively, 10 and 9 are really close to each other, but 10 is just 1 unit larger than 9. So I'm going to split it so that it looks like that. So here we go. Draw along with me. And now let's label. This piece is the bigger part. So this length is going to be 10. And then this is my very close in size part. So I'm going to make that 9. And then together, they both added back up to our factor of 19. I'm not done labeling because we know we label it on all sides. So this length is 10. This length is 10. Opposite sides of a rectangle are equal. If this length is 9, this length is 9. Good job. Perfect. So now that we have all of our dimensions, I'm going to get my pointer ready. And I wonder if you can yell stop at the correct stop. Here. Oh, keep going. All right. Here. Oh, keep going. Here. Oh, I went too far. All right, let's go back. It's now time to do the distributive property. All right, I'm going to need your help telling me the number sentences for each one. Let's start with this rectangle. What's the length? Yes, 10. What's the width? Yes, 70. Tell me our number sentence. 70 times 10. Perfect. Let's head over to this part of my rectangle. What's the width? Thought I was going to say length. Yes, 3. What's the length? Yes, 10. Talk to me about the number sentence. Yes, 3 times 10. Which part of the rectangle would you like to do next? We can do any one. Let's go here. What's the width? It is 3. What is the length? Yes, it is 9. What's our number sentence? 9 times 3. Last one. Would you, I can't give you my marker, but you can do it on your paper. Make your circles just as neat as mine. What's the length? Yes, it's 9. What's the width? Yes, it's 70. Talk to me about the number sentence. 9 times 70. Perfect. Now that we have our distributive property number sentences all set up, let's actually find the partial products of each box. Which box do you want to start with? Yeah, we can do this one. That's fine. 9 times 3, I knew this one as a fast fact, that's 27. All right, which box is next? Oh, this one or this one? This one? All right, let's go for it. 3 times 10. Yes, 30. You're really confident here. That's good. 70 times 10. Wow, 700. Talk to me about 9 times 70. That one feels like it might be a little tricky. Let's break it down. Start with your non-zero digits. So that's 9 times 7. What does that equal? 63. Now, which number? Oh, look, this factor here is a multiple of 10. So we're going to do 63 times what? 10. And we're only going to do it once because only one factor is a multiple of 10. So 63 times 10 equals what? I know you knew it. 630. Go ahead and get this all down on your paper because then you can meet me at the next step. Now we're headed over to adding our partial products. You know what Miss Tamal loves to do. I like to add 2 numbers at a time. It really just helps me. So let's get ready to do so. All right, I'm going to start with the larger numbers first. 700 plus 630. Starting at the ones place, 0 plus 0 equals 0, 0 plus 3 is 3, 7 plus 6 is 13, and we cross it out to say that we're done. Let's go over, add another number. Making sure I copy it correctly. And I'm going to add 30 this time, so plus 30. That equals to, starting at the ones place, 0, 6, 3, 1,360. Last partial product, 1,360 plus 27. Starting in the ones place, 7, 6 plus 2 is 8. 3 plus nothing is going to be 3, 1, bring that down, 1,387 is our final product. And if I wanted to double check, of course, I could decompose my factors in a different way to double check. So right now, before you go ahead and practice your own double check in your marble notebook, I'm going to give us an opportunity to work on another example. At this moment, feel free to press pause, and in your marble notebook, start to double check this, decomposing your factors in a different way, and you should end up at the final product, 1,387. Great. So now that you've worked on that, we're going to now go ahead and move forward and just take a second to capture what we've just learned here. What must we keep in mind when multiplying two-digit numbers? Go ahead and feel free to press pause so you can jot down your notes and use your mathematical vocabulary, and then press play when you're ready. Perfect. So now you've finished double checking. I saw that you got 1,387, 2 thumbs up to you. Here we get to try another example while I'm still here with you. So 54 times 38. 54 times 38. Go ahead and write it down in your marble notebook. And let's start the conversation. How did you decompose 38 into addends? Let's do it by place value this time, by place value. Okay, I'm not going to show you anything yet. Let's move on to 54. How did you decompose 54 into addends by place value? Yes, good job. You decomposed 54 and you decomposed 38 so that your words look like this. Nice work. Now, feel free to pause this video and finish your area model, distributive property number sentences, and then adding all your partial products, and then we can check our work together. All right, let's see. This is what your area model should look like with my dimensions all around. Here it is now with my partial products after I applied the distributive property. And let's check out this final product. Wow, 2052. Okay, did you get that too? I'm just seeing your face just light up with so much joy that I am at a loss for words. Good job, mathematician. So now it's time to go back to your stop and jot. Go ahead and add on. What must we keep in mind when multiplying 2-digit by 2-digit numbers? What else have you learned? So now we've reached a checkpoint. So what are some key things we want to remember when multiplying numbers? Go ahead now and jot down a few thoughts in your marble notebook or on your packet on page 1. Let me see. Hold it up to the camera. I love that one so much, and it matched my first point. So decompose the factors that are larger than 10 into its addends. This is helping us now as we continue to learn how to multiply larger numbers. But of course, as you continue to multiply later, you might find that you actually know certain fast facts like this. Multiply each addend by the other factor. This is when we're using the, which property? The distributive property. Excellent work. And then our last big idea that's going to help us when we're multiplying by multiples of 10, 100, or 1,000. So that was our checkpoint, and that's going to get us all geared up and ready to go for our independent practice. Choose your door. Ooh, door number 6. I don't think we've been to a door number 6 in a while. You will now have 15 minutes to find the product of different 2 by 2 multiplication problems on page 2 through 4 of your packet. Go ahead and make sure to show all your work. And I can't wait to see your area models that are broken down by the correct number of parts and also considering the relative size of each of the addends that you decomposed. So now you will have 10 minutes to complete your exit ticket on pages 5 and 6. And then take a picture to submit to your teacher on Google Classroom. Feel free to hit pause and then play when you're ready. So it is now time for us to depart. But guess what? You now get to wait for your teacher so that you can continue to challenge yourself with story problem. As you know, your brain is beautiful, your brain is large, so I can't wait to hear how are you visualizing, acting out, or even creating a mental movie of your story problems. So until next time, but I want to leave you with this little token. Before you go, remember, you are always in first place when you've tried your hardest on challenges. And why? Because that is when your brain grows the most, through trying on difficult challenges. You always learn something new. See you next time.